Hey, what's going on, guys? So, what we're going to do today is we're going to talk about relations and functions. Okay. Now, if you forgot, a relation is just a set of ordered pairs. A function is a special relation where every input has a unique output. Okay. So, I'm going to start off with a real-world example that relates functions and relations. All right. We're in high school, so let's talk about dating. Kids date, what have you not. So let's say we have our buddy Jim. Okay. Let's say Jim dates Sarah. Okay. Jim and Sarah have a relationship, or they have a relation because it's a set of ordered pairs. Jim is the first part, Sarah is the second part. Okay, that's a relationship. It's a set of ordered pairs. In order for this to be a functioning relationship, Jim can only date Sarah. Jim can't date anybody else. Okay, so let's say that Jim on the side dates, I don't know, Sarah's sister, Tara. All right, this is still a relationship because Jim is dating Sarah. That's a relation. Jim is also dating Tara. That's also a relation. But is Jim in a functioning relationship? Well, the answer is no, because Jim dates Sarah, but Jim also dates Tara. Therefore, Jim is two-timing Sarah and Tara, so neither of these relationships are functioning. Okay? That goes with the definition of a function because it's a special relation where every input has a unique output. Therefore, Jim, aka our input, does not have a unique output, aka his girlfriend, because he has two girlfriends. Okay? In a nutshell, that's functions and relations. All right? So let's look at a mathematical example. So we have 3, 2, 7, 12, -4, 7. Okay? We know that this is a relation because it's a set of ordered pairs. We have 3, 2, 7, 12, -4, 7. All right? What I want to know is this a function? In order for this to be a function, every input must have a unique output, aka each input can only have one output. So let's look at our inputs. We have 3, 7, -4. Do any of our inputs repeat? The answer is no, so it is a function. All right? Because all of our inputs are unique, none of them repeat. All right, let's look here. We have -2, 6, 4, 6, 5, 6. This is a relation because it's a set of ordered pairs. Is it a function? Well, a lot of kids look at this and they say, no, Mr. Flores, it's not. But a function, the definition is every input has a unique output. Well, our inputs are -2, 4, and 6. Do any of those inputs repeat? The answer is no. They all go to the same number, so they all go to 6. But we don't care about our output during a function. We care about an input. Every input is unique, so it is a function. All right, let's keep chugging along. I'll do one more example. Let's do 2, 7, 3, 6, 2, 0. All right, we want to know, is this relation a function? Well, a function, again, every input has a unique output. Let's look at our inputs. We have 2, 3, 2. Well, 2 comes up twice. 2 goes to 7, 2 goes to 0. Therefore, every input's not unique, so it's not a function. Hey, all right, so sorry about that. I had to stop real quick. All right, so the next thing about relations and functions is something called domain, something called range. All right, your domain is your inputs. Your range is your output. Okay. In a nutshell, that's what it is. Domain and range, it's something that comes up a lot on standardized tests. We don't do that much with it in Algebra 1, but if this is for your Algebra 2 class, we do A little more with domain and range in Algebra 2, but we'll get there when we do that. And if you decide to take pre-calc, you're going to do a lot with domain and range. So basically, let's say we have this 0, 7, 3, 6, 5, -2, I don't know, 3, 7. Okay. Now, right off the bat, let's see, is this a domain? Is it a relation or is it a function? Well, the x's repeat because 0, 3, 5, 3. 3 comes up twice, so it's not a function. So that's the first thing we know about this. But the second thing is, let's list our domain. Let's list our range. All right. So we're going to look at domain. Just label from least to greatest your x values. So the first x value is 0, then it goes to 3, then it goes to 5. Since 3 repeats twice, you don't have to list it twice. And your range is your output, aka your y value for an xy coordinate. We have -2, 6, 7. In a nutshell, that's it. That's all domain and range is. It's your input and your outputs. The last thing we want to talk about is ways to write relations / functions. Okay? So basically, the first way we can write them is the way that we just wrote them. Okay? As ordered pairs. So that's the first way. All right? So ordered pairs is 3, 7, -2, -5, 2, 10, and let's say, I don't know, 0, 4. Okay, that's an ordered pair. You've seen it before. The next way you can do it is called a table. I hope everyone's seen this. This is literally just an XY table. The way you write this is you make sure your x's go in least to greatest. So the first x would be -2, which goes at -5. Then it's 0, which goes with 4, 2, which goes with 10, and 3, which goes with 7. Okay, that's the second way to represent a relation or a function. The next way is called is called mapping. Okay, basically, you put your x's in one big bubble, your y's in another big bubble, and you list them from, again, least to greatest. So it's -2, 0, 2, 3. Then it goes -5, 4, 7, 10. And you're going to map or draw a line from the x to its corresponding y. So the x is -2, -5. Just happens the line goes straight across. Okay. Then 0 goes to 4, goes straight across. 2 goes to 10, and 3 goes to 7. Okay, that's a mapping. The last way is everyone's favorite. Well, that's a lie. It's not everyone's favorite. And that is graphing. But again, when we talk about graphing, sorry, the graph went all the way up there for some reason. We're talking about, on a coordinate plane. Okay, so all you're going to do is you're going to graph it. So we're going to do 3, 7. 1, 2, 3, 1, 2, 3, 4, 5, 6, 7. 3, 7, -2, -5, 5, 2, 10, and 0, 4. Okay, and then this would be our graph. All right. So basically, those are the 4 ways we can identify a relation or a function. Okay, but let's ask ourselves: is this a relation? Well, I mean, is it a function? Well, we have 3, -2, 2, and 0. Those represent our 4 coordinate pairs. It's a function because none of the x's repeat. But let's say I add this 2, -5. All right. Something that you learn to see if a graph is a function, it's called a vertical line test. Okay, we know right off the bat this is not a function because 2 repeats itself. Okay, and this is called a vertical line test. And the vertical line test checks to see if the graph of a relation is actually a function. So I'm going to go ahead and graph this. It's going to be down there. The vertical line test says that if you can draw a vertical line, wow, that's terrible. If I can draw a vertical line that goes through 2 points, then it's no longer a function. So if we look here, when I draw my line, my vertical line, through x equals 2, it hits 2 points, so therefore it's not a function. This is a way you can check and see if a relation is not a function graphically if you're not given the coordinates. Okay. Again, that's the vertical line test. It's pretty self-explanatory. And again, in a nutshell, this is relations and functions. I know it's a long video. There's a lot going on, but if you have questions, let me know. Hope you learned something.